Good morning, pre-calc kids. This is Miss LaFour, and today we're looking at 9-1, sequences and summation notation. So when we have sequences, we have two different types, infinite, which goes on forever, and then finite, which stops at some point. There's only a certain number of them. These terms of the sequence are denoted by subscripts. So notice how you have a sub 1, a sub 2, a sub 3, a sub 4. It continues on. So let's jump right in to example 1. Write the first 6 terms of the following sequences. So here we have a sub n equal to n minus 1 over n plus 1. So the first thing we do is plug in 1. So we'd have the first term would be 1 minus 1 over 1 plus 1. So it's 0 over 2, which is 0. So our first term is 0. Second term, we plug in 2 for n. So this would be 2 minus 1 over 2 plus 1. So that's 1/3. Third term would be plugging in a 3 for n. 3 minus 1 over 3 plus 1. So it's 2 over 4. Well, that can simplify to 1/2, so I'm going to go ahead and simplify it. The fourth term would be plugging in a 4 for the n. So 4 minus 1 over 4 plus 1. That's 3/5. The fifth term would be plugging in a 5 for the n. And that gives us 4/6, which is 2/3. And then the sixth term, which is the last one we need to find, we'll be plugging in a 6 for the n, and we get 5 over 7. All right, so we have our terms. So our first 6 terms would be 0, 1/3, 1/2, 3/5, 2/3, and 5/7. Notice how on part B it's a little bit different, but it's still, they're using B instead of A, but the subscript is still there, of course. It says, so the first term here, B sub 1, would be -1 to the first power over 2 times 1, which would be -1 times 2, which is -2. Second term, this would be -1 squared over 2 times 2, which is +1 times +1, which is 1. The third term would be -1 to the third power over 2 times 3. So that's -1 times 2/3, which is just -2/3. All right, let's see, the fourth term would be -1 to the fourth over 2 over 4. So that's a +1 times 1/2, so that's 1/2. B to the fifth is plugging in a 5 for the n, and I get -1 times 2/5, which is -2/5, and B to the 6th, the last one we need to find, 2 over 6. This would be a +1 and a 1/3, so that's 1/3. All right, I'm sort of running out of room here to write these. Let's see if I can squeeze this in somewhere. So my answers are -2, 1, -2/3, 1/2, -2/5, and 1/3. So these are the first 6 terms of that particular sequence. Now notice how on this one we are going from negative to positive to negative to positive to negative to positive. And that is from this piece here. Let me see if it'll highlight. Okay, you see how it's got -1 to the n power? That's what's making it change signs every other term. That's going to come in handy if we know that fact in the next little part. Okay, now this next part is using a recursive formula. This is the part that some people had issues with before. Like it's harder for them to see as students as the first time. Initially, we were given explicit rules. So the one we did before, a sub n is equal to whatever, and we just plug in the certain n, that's explicit, it explicitly states, it just flat out tells you what it is. The recursive formula is only defined based on the previous term. So that's what confuses people. So notice how in our thing, they tell us the first time, a sub 1 is n, they tell us the first term, and then they say every other term after that is relative to it. So notice they have a sub n here, and then they are saying, well, it's 2 times a sub n minus 1 plus 3. So that's like taking, the number you start with, and every other one after that, you just have to multiply by 2 and add 3. So this is a recursive formula, that a sub n minus 1. So don't let that freak you out. Let me show you how it works. Okay, so if our first term is 7, I'm going to go ahead and put 7 right here. I know the first term is 7. They gave it to us. The next term is found by saying 2 times that first term plus 3. So that's 14 plus 3. That's 17. So that's the next term. Okay, so then the term after that is 2 times that term, 2 times 17 plus 3, which is 34 plus 3, 37. Okay, so that's the third term. Then the next one's found by saying 2 times that number plus 3. 74 plus 3 is 77. So that's this number. And then the fifth one, we're multiplying by 2, adding 3 again, and we get 157. So the key is to remember that when you have a recursive formula, you're always taking the number in front, and that's what's getting plugged into the next piece. You see, like here, we're taking 37, plugging it into there. Then the next one, we're taking 77 and plugging it in. So, the pattern's a little bit different. Look at part B. Here we have our first term is 5, or negative 5. So negative 5. And every other term after that is found by the number in front plus 10. Oh, well, this one's actually pretty easy then, because that means all I'm having to do is say that term plus 10. So that would be 5, the next one. And then 5, add 10 more, that's 15. Add 10 more, that's 25. Add 10 more, that's 35. Okay, so we have negative 5, 5, 15, 25, 35. We almost didn't even need to write that step out, but there you have it. Okay, so on example 3, we are looking to write a recursive rule for the sequence. So first thing you want to do is notice what's happening to each part. So here, notice we're going, let's see, this is adding 3, adding 3, adding 3, adding 3. So that means clearly you're adding 3 to each one. So for a recursive form, you always have to say what the first term is. So the first term, a sub 1, is 1. And then a sub n, which means any other term, is found by taking the term in front of it, which is a sub n minus 1, and then adding 3. So this is our recursive rule for this particular sequence. On the next one, on part B, notice, let's see, what are they doing? This is minus 5, right? Minus 5, minus 5, minus 5. They're giving us some easy ones here to start. Our first term is 4. And every other term after that can be found by taking the term in front of it, which is a sub n minus 1, minus 5. Now the next little part is factorial notation. You may or may not have seen this before, but it's the exclamation point, okay? And it means factorial. It means multiply every number from integer from that one down to 1, okay? So like if we want to do n factorial for n of 1, 2, 3, 4. So if I do 1 factorial, this is just 1. 2 factorial would be 2 times 1, which is 2. 3 factorial would be 3 times 2 times 1, which is 6. 4 factorial would be 4 times 3 times 2 times 1, which is 24. So you're just multiplying every number from that number down to 1. That is what that means. So notice on part B, we have a sub n is 2 to the nth power over n minus 1 factorial. And we're going to do the first 4. So the first term, a sub 1, would be 2 to the first power over 2 minus 1 factorial. So 2 to the first power is just 2. 2 minus 1 is 1. 1 factorial is 1. So this is 2 over 1, which is 2. Okay, the second term would be 2 to the second power over, why did I put a 2 in the first one? Oh my goodness, I just noticed that. You probably already noticed. This is not supposed to be a 2 here. All right, this is supposed to be a 1. 1 minus 1 is 0 factorial. And 0 factorial is also 1, by the way. So I didn't change my final answer. Okay, so the next one, we're plugging in a 2 for n. So 2 minus 1 factorial. So this is 4 over 1 factorial, which is 4 over 1, which is 4. Okay, a sub 3 would be 2 to the third power over 3 minus 1 factorial. So 2 to the third is 8. This is 2 factorial, which is 2. Okay, so that's 4. Oh, let me scroll down to try to squeeze this one in. The fourth term would be 2 to the fourth over 4 minus 1 factorial, which is 2 to the fourth, that's 16. 3 factorial, so it's 16 over 8, not 8, 6, which gives me 8/3. There we go. Now on this next page, we are evaluating fractions with factorial notation. So notice at the top on part A, we have 12 factorial over 2 factorial times 10 factorial. So this actually means 12 times 11 times 10 times 9 times 8 times, oh my goodness, 7, 6, 5, 4, 3, 2, 1. Okay, don't reach for your calculator just yet, okay? On the bottom, I have 2 times 1, and then I have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, so I'm wanting you to notice that all of these will cancel with all of these. So I didn't really need to even worry about that. And then I could also say, well, divide by 2. So this is just 6 times 11 on top. So that's 66 over 1, which is just 66. So you didn't necessarily need a calculator for that. Just want you to know what it means. You don't necessarily have to write it out. Once you see what it is, you don't have to write it out every single time. Now notice on part B, we have n plus 2 over n. It's the same basic concept. This would be n plus 2 times 1 less, so that would be n plus 1, times 1 less, which is n, times n minus 1, times, oh my goodness, how did I change colors accidentally? That's funny. Okay, n minus 2 all the way down to 1, right? On the bottom, we have n times 1 less, times and 1 less, times all the way down to 1. So notice that all of these will cancel. So what is left? Just n plus 2 times n plus 1. And you could multiply that out if you wanted to, but we don't need to. Now this next part is summation notation. My guess is you probably haven't seen this before. This shows up in calculus, so if you're ever going to take calculus, you kind of need to know what it means. And it's a big Greek letter. It's called sigma, and it means summation, the sum of whatever the thing is, okay? So notice on the bottom here we have, like, you're starting with the 1 down here. This is your starting point. That's what you put in, your lower limit. And then you go to your upper limit, which is whatever number's on top of that big symbol there. And then and that big sigma notation just means sum. So find the sum of the items in the sequence. So we're going to work these out here, like on example 6, and let you see what I mean. So notice here I'm starting with 1, and I'm plugging it into this piece here. I'm plugging it into this thing. So they're saying I is going from 1 to 5, and I'm plugging it into that piece. So this would be 1 squared plus 2. That's my first term. Plus, then I plug in the 2, so 2 squared plus 2. Then I'll plug in the 3, 3 squared plus 2. Then I'll plug in the 4, and I'm running out of room, so I'm going to start on this one, so that's 4 squared plus 2. Then I'll plug in the 5th term, so it's 5 squared plus 2. And then I'm done. Then I can add all that up. Okay, so that gives me, let's see, what is that? 3 plus 6 plus 11 plus 18 plus 27. So that's a grand total of 65. All right, so let's check out the next one on part B. Here we're starting at a k of 3, so I'm plugging in 3 for the k here into that expression, and then I'm stopping at the 7. Then I've got to add all those together. So if I plug in 3, I get negative 1 to the 3rd power minus 3. That would be the first one. Let's see, then 4, oops. The next one would be 4, so minus 3 here, okay. And then we have 5 is the next one. Then 6. Then 7. Okay, then we add them all up. So this would give us negative 4 plus negative 2 plus negative 4 plus negative 2 plus negative 4. Oh, that's interesting. Okay, so that gives me negative 16. Okay, on this example 7, express each sum using summation notation where I is 1 is the lower limit of the summation notation. Okay, so when they tell us if we want to use I is 1 as the lower limit, it kind of limits what it's going to be, because we could make some changes on it, but that means we'll all have the same answer, which is pretty good. So notice here when I'm looking at the problem, I'm looking at what is changing each time. And of course, this tells me a lot right here. Okay, see how it's got 1 over 3 to the n minus 1? So I know that's important. So here we got our summation notation. I is going to go from 1 up to n, and this would be 1 over 3 to the I minus 1. So they kind of gave it to us there of what is changed. Okay, so basically your n is your I in this case. But on the next one, notice how this one is. Okay, so notice what's changing. This value right here is what's changing each time. Everything else is staying the same. So when we go to write this one, it's the summation. I is going from 1, because they said we got to start to 1 with 1, and that is our first term if you notice. And notice we're going to the 4, so the 4 would be up here. And then it would be 2, and then it would be I over 4 plus 3, because that is the expression. Now on this last page, it's going to be the very nice part of it, the part you're going to like, and that's using technology to do this. Okay, there's other ways, and I took that out of the lesson because you can do it without, but I'm just going to let you do it with a calculator. And this picture here kind of shows you what you need to do. Okay, so if you notice, if you go under the math, and then the 0, you just tab down, okay, till you get summation right there. and then it's going to pop it up, and then you just have to fill it out like this, and it'll give you the answer. So that's what we're doing here. So on your calculator, go to Math, and then tab down to where you see Summation, and it's got that little symbol, okay? That's what you're picking out. And then you're just typing all that in. And you don't have to use a K, use an X, use an X there, it's fine. So I'm typing in under the summation, X equal 1 to 24. And then it's going to be, parentheses already going to open for you, X squared minus 5X plus 4. And then hit your equal sign, and you get 3496, and boom. So nice to know. Now this next part is annuity and amortization formulas. That's all finance stuff, and that's using a different mode in the calculator. We are not going to do that. But if you do plan on going into finance or accounting, you will probably do that in your future. All right, we are done.